What you're looking at here, you can't see it because I've whited it out, but I've got randomly selected data points in the blue curve right here. They're between 0 and 20. Between 0 and 20, okay? You've actually given me something to think about for this too, Carly, by saying that, thank you. They're hidden back here. They're in this little column right here. Each of those bad boys, that's an example of the command. This is the kind of crap you'll be playing with in this class. Not expected to know how to do right now, but you'll be playing with this. See that RAND up there, that RAND? That's a random number generator in Excel. I love those because that way we get bias-less or less biased data than trying to, for example, think of a whole number between 1 and 4. And you all say 3. That's bias. For some reason we're biased to 3. Excel doesn't have that bias with the random number command. It just generates random numbers. What I've done here is, I forget how many I've done. I think there's like 1,000 or something. There's a whole bunch of them. And this up here is the graph of those numbers. That blue one right there in the front is the graph of those numbers. It's a graph of those numbers. Fair so far? Good so far. Okay. So you've got this bad boy right here. The average of the raw data is going to be 10. The average of that raw data is going to be 10. It's halfway between 0 and 20. We've got 10 right there. Okay. Now, what's cool about Excel in this case is when I press F9, I get, I think it's 1,000. I think pretty sure it's 1,000 data points. I get 1,000 new ones randomly generated. Now, what shape is that blue? What shape is that blue curve? If you've taken a psych class, you know this, the answer to this, right? You might not know the answer to this yet, and part of this class will teach it to you. That's a bell curve, otherwise known as a normal distribution. That's why whoever said normal yesterday, Marty or whoever it was said normal. I said, I love that, but there's another name that we use normal, another context we use normal for. Totally cool, though. Use it conversationally. This bell curve right here is a normal distribution, okay? Now what I've done, and you've given me something to think about, Carla, but write down the phrase so don't forget it. I've then broken the data into groups of, it looks like 3, 0 through 2, 3 through 5. I think it's the same grouping that I did for the keys. So now, on the red curve behind that, these guys right here, 0, 0, and 2, have been grouped into a group that just says 2. There are 2 numbers between 0 and 1. There are 34 between the next 3, because it's 6, 26, and that's not quite right. It's 2, 6, and 26. So if you add 8 plus 26, you get 34. So in other words, the blue graph is the raw data. The red graph behind it is the grouped data. If that makes sense. Hopefully that makes sense. So the next one, 0, 1, 2, 3, 4, 5, 6, 7, and 8 looks like it's 37, 94, and 117. So I've called that 248 because it's the sum of those 3 things. So I'm losing the raw data and only grouping it. Now I've chosen a width of 3. I'm going to remake this so it's got different groups too. That's good. Very, very good. Notice this bar is huge up here, yes? Compared to this bar right here. That's because this bar represents the sum of the 3 middle bars. So there's 1/3 as many bars in the red graph as there are on the blue graph, because I've grouped the blue graph 3 at a time, which only has 7 bars versus 21 in this case. Let's make sure we understand that before we go any further. So I've done the same thing that we did with our keys, but I'm doing it with Excel now. Now notice the shape of both curves. Now, granted, the red one's taller than the blue one, for sure. But what's the red one shaped like? A tall, skinny bell curve. And it should be, because it's echoing the distribution of the blue one, even as it dances. Okay? Even as it dances. Alright? Now, here's what I really want you to focus on. Clearly, over here, let's look at this bar that says 32 right now. 32. There are 32 data points in that bar, yes? That's because it's 3 3s, I think it's a 3. I think I'm reading that right. Is that a 5? 5 3s, 9 4s, and 18 5s. Now here's the problem. We're going to call that bar 4. 3, 4, 5. We're going to pick the middle value of 4, yeah? The problem with that is we've picked a middle value, but there are more 5s than anything else. Correct? So we're going to say there are 32 4s, but that's actually an underestimate of what's actually in there. There are actually more 5s than anything else, yeah? That's a problem, right?
Unless you distribute the 5s, some of those 5s over.
But we can't. Good, Linda, thank you. But we can't because we don't actually see this blue distribution. We get the red one behind it from our data. This might be a graph you see in a data set, in a journal, in which case they hide the blue data from you. Very good point. So you can't distribute it. But do you see how it's taken care of somewhere else in the curve? Alan, what do you see?
Group 6, 7, and 8. you're gonna pick 7, and there's more 8s than there are
Let's
7.
see. 0, 1, 2, 3, 4, 5, 6, 7, 8. We're going to pick 7, but there are actually more 8s than 7s. Which means we're doubly screwed. Because now we've underestimated that one too, haven't we?
Yeah, but it's gonna offset.
Actually, I think it makes it worse. Because now we've underestimated this bar and we've underestimated that bar. Because we picked the middle value. I see what you're saying, Alan.
But we've overestimated the ones at the end.
On the other side, though, these two have been overestimated, right? Because this bar right here, let's look at this bar. This bar right here is 15, 16, and 17. That bar. We're gonna call that bar 16. Which means we're assuming, as Linda implied, that there's an equal number of 15, 16, 17. But that's overestimated. There's more 15s than anything. So this bar compensates for this bar. This bar compensates for this bar. How about this bar in the middle? How about the bar in the middle? What do you think? It's a bit of a trick question.
Wouldn't it compensate for the outer?
It compensates for itself.
Yeah.
The middle value, you may have noticed that 10, it sometimes is a little bit off. Like right now, 9, 10, and 11 are rising as they go left to right, but watch that middle bar of 10 as time goes by. What do you notice about that middle bar of 10?
On occasion.
It spends a lot of time at the top because it's the average. It should. It should be popping up at the top there, yes. And now, the grand finale. That's the average, is definitely 10. Watch that grouped data average, the one like we just calculated. This is calculated the exact same way we just calculated ours. X times F, X times F. Watch that and describe what's going on as we hold down F9. Where's my stapler? Someday I'm going to take CIS 121E. Learn how to program this damn thing, so I have to hold it down with a stapler.
Make sure you don't take it on
Make sure you don't take it online.
the, yeah.
I may have to. I have a 6-year-old.
Oh gosh, take it online.
Boom. Okay. What do you notice about the group data average versus the actual average of the data if we had the raw data?
It stays around 10.
Oh, say that again!
It stays around.
It's like watching evolution, Nick.
Yes.
It's like watching, well, the best quote I've heard in a long time in class. Yes, it's hovering around 10. Sometimes a little below, sometimes a little above. But on average, it's right there at 10, yeah? On average, it's right there. That's the point. The point is, yes, you sacrifice some precision when you're given the grouped data, but you can still pull the numbers you need off the distribution within a realm of error that's acceptable. Cool, huh? Pretty slick. Yeah. All right. Let's take 5. That was a lot. I'll have to process. We're going to dance for a while if you guys want to dance. This is the best part of statistics, is watching the data present itself to you. Yes, I think so anyway. Yes.
It never goes up to 11.